Good morning. Today's lesson is 6.7, but before we begin, a word from Madison.
I love donuts, so is my mommy, and we play with donuts. My lesson on 1, 2, 3. My lesson is 1, 2, 3.
Okay, so today's lesson is subtraction with renaming. Our essential question: how can you use renaming to find the difference of two mixed numbers? So let's unlock the problem. To practice for a race, Kara is running 2.5 miles. When she reaches the end of her street, she knows that she's already run 1 5/6 miles. How many miles does Kara have left to run? Well, first let's underline the sentence that tells us what we need to find. So the sentence that we need to find is how many miles does Kara have left to run, right? We need to underline that. Next, it asks us, what operation should we use to solve the problem? Okay, so the operation that we're going to need is subtraction. Because I want to know how many miles does she have left to run, right? So I need to take the 2.5 miles and the 1 5/6 miles and find out how much I have left over. So we're going to subtract 2.5 minus 1 5/6. Let's estimate the difference. So 2 1/2 is closer to, well, it's close to 2.5 if I'm using benchmarks. And so there we go. Minus 1 5/6, well, that's close to 2. So let's change that to 2. So if I'm minusing that, 2 1/2 minus 2 is going to be 1/2. So my answer should be close to a half. All right, step 2. We're going to find a common denominator. We need to use common denominators to write an equivalent fraction with like denominators. So if I'm looking at 2 1/2 and I'm looking at 1 5/6, 6 and 2, a number that 6 and 2 both have in common is 12. So you can see right here where they already renamed it. I kept my 2 whole and I kept my 1 whole, but I did rename the bottom. So if you're going to rename 2, if you're going to rename 2 1/2 into 2 6/12, what they did, I'm actually going to do it over here because I don't like the way they did on this think part. So if I have my 2 and my 1/2, and I want to make it be 2 and something with a 12, what do I need to do to this? Well, the bottom number, in order to make it be 12, has to be multiplied by 6. So whatever I do to the bottom, I do to the top. 6 times 1 is 6. So that's why I got 2 and 6, 12. Okay, so then I need to rename this, and you can see that they already did that there. Let's change this font. So 1 5/6. And in order to rename 1 5/6, remember I want it to be 12 on the bottom. So the way they got that 10 was, in order to make the 6 on the bottom 12, I had to multiply it by 2 over 2, right? And 5 times 2 is 10, right? So that's how they got the, that is how they got the 1 and 10 12s. Now, the other part, let me erase this. The other part that's important is I can't subtract 6 from 10, so I kind of need to regroup, and that's why they have this rethink. So what's another way that I can write 2 and 6/12s, right? So if I take this 2 away, if I take this whole number 2 away, it's worth 12 over 12, right? That whole is worth 12 over 12, which would leave me 1 here, and I have my 12. So if I've got this 12 plus this 6, then I'm going to have 18 on the top. And I know having a bigger number on the top is kind of funny, but I need to do that because I have to subtract. So I'm going to make this be 1 and 18 12s. That way I can take the 18 from the 10. The 18 from the 10 is going to give me 8 12s, right? And then I have 1 subtracting 1, which is 0, so I don't do anything there. I can reduce. 2 can go into 8 and it can go into 12. But so can 4, and 4 is a bigger number, so let's do that one instead. 4 goes into 8 2 times, and 4 goes into 12 3 times. So my final answer is going to be 2/3. So the difference that Kyra has miles left to run is going to be 2/3. So why is it important to write equivalent fractions before renaming? So like how I made the equivalent fractions up above. Well, it's important because you need to write them so that you can determine whether you need to rename, right? So like up here we rewrote the equivalent fractions, and then we had to rename this fraction in order to have enough to be able to subtract from. Okay, so let me put this back down here. So another way, we're going to rename both mixed numbers as a fraction that's greater than 1. So we're subtracting 2 and 1/2 by 1 and 5/6. So we're going to write equivalent fractions using the common denominator. So a common denominator of 1/2 and 5/6 is 6, right? So we want 6 to be on the bottom of both of these. So I'm going to put 6 on the bottom. So we have 1, and we're going to make sure that 6 is on the bottom. We've got 2, and we want to make sure 6 is on the bottom. There's already 6 on the bottom of this one, so I can leave it the same. I don't have to do anything to change this one. But on this one, I have a half, and if I want 6 to be on the bottom, I have to multiply it by 3 over 3. 3 times 2 is the 6 that I needed on the bottom, and 3 times 1 is 3. Now, step 2 says rename both mixed numbers as fractions that are greater than 1. Okay, so here I have 2 and 3/6, and I have 1 and 5/6. So if I want to rename these as something that's greater than 1, I'm going to make it a mixed number. So that means multiplying 6 times 2 and adding the 3 and putting it over 6. And I know we've done that before, right? So 6 times 2 is 12. Plus 3 is 15. So my top number is going to be 15. My bottom number is going to be 6. Okay, so let's go ahead and do this one. So now we have 6 times 1, which is 6. And then you're going to add the 5, which is 11. So my top number is going to be 11. And then I keep the same number on the bottom. So now I can find the difference. I can do step 3. I can find the difference of the two fractions. And then I'm going to write the answer in simplest form. So I have 15 over 6 minus 11 over 6. So 15 minus 11 is 4, and then I have it over 6. Now 4/6, I've got to reduce that. 2 can go into 4, and 2 can go into 6. 2 goes into 4 2 times, and, 2 times, and 2 goes into 6 3 times. So the answer is 2/3. Okay, so the answer is 2/3, the final answer. So that means 2 and 1/2 minus 1 and 5/6 is 2/3. So let's do the share and show now. So first we're going to estimate. So let's look at the problem and estimate. We have 1 and 3/4. 1 and 3/4. 3/4 is close to a whole, right? So I'm going to say 2. 1 and 3/4 is closer to 2. Minus 7/8. Well, 7/8 is only 1 away from a whole. So we're going to say minus 1. And 2 minus 1 is 1. So our answer should be close to 1. So I've got 1 and 3/4 minus 7/8. First of all, we're going to write it so I have 8 on the bottom, right? So that in order to make this 4 be an 8, I'm going to have to multiply it by 2 over 2. So I'm going to have 1, and that is 6, and that is 8. So I'm going to have 1 and 6/8, and let's just move this over. Minus 7/8. Now I cannot take 6 from 8, so I'm going to have to regroup. That means I'm going to have to take this whole away. And remember, this whole number is the same thing as an 8 over 8, right? So 8 plus 6 is 14 over 8. And then I have my 7/8. Okay, so now this is my new subtraction problem over here. 14 from 7 is 7, and then I keep my 8 on the bottom. So the answer is 7/8, and 7/8 is close to 1, so my estimate was close. So let's do the next one. Let's estimate again. 12 and 1/9. Well, that's going to be close to 12. Minus 7 and 1/3. Well, that's closer to 7 and 1/2. So 12 minus 7 is 4 and 1/2. So that's going to be my estimate. So now let's actually solve it. I've got 12 and 1/9 minus 7 and 1/3. So again, I've got to write it out in equivalent form first. I need to make the bottom numbers be the same. I can keep the 12 and 1/9, and I can try and change this into 9ths on the bottom. So this would be 7. And in order to make the bottom be 9ths, I'm going to have to multiply it by 3 over 3. 3 times 1 is 3. 3 times 3 is 9. So now, let me get rid of this. So now my problem is 12 and 1/9 subtracting 7 and 3/9. I can't take 1 from a 3, right? So I'm going to have to borrow from here. Okay, so if I take 1 from here, I'm going to make this be an 11 whole. And if I'm taking 1, remember, a whole number can be whatever I put on the top and the bottom is 9 over 9. So that means right here I'm going to have 10 ninths. Okay, so this is going to now go away. So now I have 11 and 10 ninths subtracted 7 and 3 ninths. Well, 11 from 7 is 4. And then I've got 9 on the bottom because I keep it the same. And now I have 10 subtracted from 3, which is 7. So my answer is going to be 4 and 7 ninths. All right, so work with a partner. And I'm always on the floor if you need me. Good luck.